All right, let's dive into one of the biggest, most mind-bending ideas in all of astronomy, the hunt for alien megastructures, things so enormous they could literally wrap around an entire star.
It all boils down to this one really simple but kind of chilling question. If the universe is supposed to be full of life, then where is everyone?
To even begin to answer that, we have to face a puzzle that has haunted scientists for decades. They call it the Great Cosmic Silence.
Yeah, as far as we can tell, when we listen to the universe, it's just quiet. Eerily quiet. And this huge echoing silence, famously known as the Fermi paradox, is exactly what pushed one physicist to think, okay, maybe we're doing this all wrong. Maybe we shouldn't be listening, maybe we should be looking.
So, this cosmic quiet got a brilliant physicist, Freeman Dyson, thinking way back in 1960. He came up with a completely radical new kind of clue to search for.
And Dyson's logic here? It was just so simple, but absolutely brilliant. He figured any advanced civilization is going to need more and more energy as it grows, right? And eventually, where are they going to turn? To the biggest power source in their neighborhood, their home star. And trying to harness that much power, well, that would leave behind some pretty obvious, unavoidable evidence that we could spot from light years away. Now, to really wrap your head around the sheer scale of a project like this, it helps to know about something called the Kardashev scale. It's basically a way to rank how advanced a civilization is by how much energy it uses. And a civilization that could actually build what Dyson was talking about, a Dyson Sphere, they would be what we call a Type 2 civilization. That means they've mastered the entire energy output of their star.
So what on earth would this incredible piece of engineering actually look like? Let's take a peek at the blueprint for this hypothetical alien megastructure. Okay, this is a really important point because there's a huge misconception here. When you hear Dyson Sphere, you probably picture a giant, solid metal ball completely enclosing a star, kind of like something from a sci-fi movie. But Dyson himself knew that just wouldn't work. It would be a gravitational nightmare. What he actually proposed was a Dyson swarm, a massive, dense cloud of individual solar collectors all orbiting the star independently, a much more plausible idea. And this breaks down the physics perfectly. First, the star shines. Second, the swarm of collectors soaks up all that energy. Third, the civilization uses that power for, well, whatever they want. But for us, the alien hunters, step 4 is everything. Because of the laws of thermodynamics, using all that energy has to create waste heat. And that heat has to go somewhere. It radiates away as invisible infrared light. That's the signature.
So that waste heat, that's our big clue. It's our breadcrumb trail. Let's look at how our cosmic detectives actually go hunting for these infrared ghosts across the galaxy.
See, the key thing to get here is that we're not actually looking for the structure itself. We can't see it. We're looking for its shadow, the effect it has. We're searching for a star that looks weirdly dim, but at the same time is glowing with an enormous, unnatural amount of heat. It's an unavoidable thermodynamic fingerprint.
And why would anyone go through all this trouble? Well, just look at that number. That's how much power our own sun puts out every single second. It's billions of times more energy than all of humanity uses. That is the ultimate grand prize. Capturing all that energy creates a really specific telltale sign. A normal star, right? It's super bright in the light we can see. But a star hidden inside a Dyson swarm, it would look strangely dim because all those collectors are blocking the starlight. But here's the trade-off. All that energy they're capturing gets radiated away as heat, making the star glow incredibly, unnaturally bright in the infrared spectrum. This bizarre contrast, dim visible light, bright infrared, that is the smoking gun astronomers are searching for. Now, this might all sound like something out of a science fiction novel, but in 2015, this hunt got very real. And it was all because of a mysterious star that the world came to know as Tabby's star. Scientists were using the Kepler Space Telescope, which is designed to find planets by looking for tiny dips in starlight, and they found something they had just never seen before. This one star, it was dimming and brightening in a way that was completely random and made no sense at all. And you want to know what made everyone's jaws drop? At one point, the star's light dimmed by a staggering 22%. I mean, to put that in perspective, if a giant planet like Jupiter were to pass in front of our sun, it would block about 1% of the light. So 22%? This was something else entirely. The whole scientific community just went into overdrive. For the next few years, telescopes all over the world pointed at this star, looking specifically for that telltale sign, that extra infrared glow, the waste heat. But in the end, they found nothing. No extra heat.
So the alien megastructure idea, as exciting as it was, had to be ruled out. The best guess now is that it was probably just a really weirdly shaped cloud of dust.
So, if Tabby's star wasn't the one, where does that leave us today? Let's take a look at the state of the search now and think about what this continued silence might actually mean.
Well, the search is far from over. In fact, it's getting way more sophisticated. Just this year, a new search called Project Hephaestos flagged 7 new potential candidates. But, and this is a big but, follow-up work is absolutely critical. For instance, one of their most exciting finds was later re-examined and, oops, it turned out to be a distant galaxy. So while the search goes on, as of right now, we have 0 confirmed detections.
And we have to be honest about the challenges here. They are immense. The sheer amount of raw material you'd need, we're talking about having to literally take apart planets in your solar system. It's just mind-boggling. Not to mention the engineering feat of keeping billions of separate structures in stable orbits. And maybe it's just a very human idea. Maybe a truly advanced civilization would find much smarter, much more elegant ways to get power.
But here's why it's still so important to look. Even if we never find one, the search itself is incredibly valuable. It pushes our technology to its absolute limits. It makes us ask these huge, profound questions about what a civilization can become. And it gives us a real, physical sign that we can actually look for out there in the dark.
And that brings us right back to the beginning, doesn't it? The hunt for Dyson spheres is really just one more tool we're using to try and make sense of that great cosmic silence. So I'll leave you with this thought. Is the silence a sign that we're actually truly alone in this universe? Or could it just be that we're the first ones to show up to the party?